Year 12, here we are again. We're looking at simultaneous equations again. This time we're looking at the elimination method. Now, we're looking at two different methods. Sometimes one works more efficiently than the other. Sometimes rarely, but sometimes you may be asked to use one particular method. It might say solve these equations using the substitution method, or solve these pair of simultaneous equations using the elimination method. Okay, substitution, we make one of the variables the subject of one of the equations and substitute in. The elimination method, what we do is we add or subtract one of those equations from the other or to the other. Okay, what we're trying to get is the same coefficient, either the same coefficient or a negative of the coefficient of one of those pronumerals. Let's see how that works. Again, remember, we need to write a commentary as we go along. Now, example 17, solve for x and y. I have two equations here and two variables, right? I want to solve this by the elimination method. And it's not a great candidate for the elimination method straight away. We're going to need to make a little bit of an adjustment to it. So I'm going to call this 1 and this 2. What I'm going to do is I want to do 2 lots of 2. I want to double the second equation. That means that 2x equals 2y minus 8. I'm going to call that 3. The reason I've done that is, right, I'm not changing the subject of that, I'm doubling this. Now I have 2x in the first equation and 2x in the second. So what I want to do now is, I am going to subtract one of those equations from the other. I'm going to say now, 1 minus 3. Take equation 1 and take equation 3 away from it. So equation 1 is 2x plus y. Oops. 2x plus y minus 2x. Right, that's the left-hand side. Right, my right-hand side now is, the first one is 7. Ooh, this is playing up a little bit. And the right-hand side of my other one, right, I'm going to take away 2y minus 8. What's going on here? Touchscreen's playing up, minus 2y minus 8. Okay, this is the first equation minus the second equation. First equation minus the second equation. 2x minus 2x, that's all gone. So I get y equals 7 minus 2y plus 8. Now I'm going to add 2y to both sides. I get 3y equals 15, y equals 5. Partway there. Now, I'm going to call that one 4 now. Let's substitute that into one of the other ones. I want to find x, so equation 2 looks good. Therefore, x equals 5 minus 4, x equals 1. So my answer is 1, 5. That's the elimination method. Okay, always works. In fact, both of them always work. Sometimes one's more efficient than the other. Right, I've got another example to look at here, then we're finished. Right, that's the end of this algebra topic. We're going to move on to revision, ready for our test on Monday. So, looking at these equations here, we've got a 2x and a 2b, a 3x and a 5b. Neither good candidates for substitution, not fantastic for elimination. Right, I've got to make a few changes here. You know what I'm going to do? I am going to triple the first equation and double the second equation, so we get 6x in both of them. So let's call this 1 and this 2. So I'm going to go 3 lots of 1 gives me 6x plus 6b equals negative 6. Now I also want to, and I'm going to call that equation 3. Now I want to do 2 lots of equation 2, because that is also going to give me 6x. It gives me 6x plus 10b equals 90. Call that 4. Now, I'm going to do 4 minus 3. You've got to make a decision here, but 4 minus 3 is going to give me the 6x minus the 6x. That's neat. 10b minus 6b, I get a positive number of b's. That's helpful. So, 4 minus 3 gives me 6x plus 10b minus, let's have a look here, 6x plus 6b equals 90 minus negative 6. That means that 10b minus 6b, that means that 4b equals, oh, that should be a 90 there, equals 96. That means that b, what's 96 over 4? Must be 24. Is that right? Right, b equals 24, halfway there. Now we are going to, so we'll better give that number, call that 5, equation number 5. Substitute 5 into, what's going to be a good one to substitute into? But I don't know, into 1. They'll all work out, it's all fine. Substitute 5 into 1, that means that 2x plus 2 lots of 24 is negative 2, means 2x equals negative 2 minus 48. 2x equals negative 50, x equals negative 25. So my answer is negative 25 and 24. If I graphed those two straight lines, then I would find that they intersect at negative 25, 24. That's it, simultaneous equations. Go through the videos. Please jot down questions, ask me in class. Yep. Yes. See you there.